This is 1.2 Functions and Graphs in College Algebra, and I'm starting on page 74. And one of the things that we're going to look at when we get started with functions is to try to make sure that you get a good grasp as far as what a function actually is. First of all, let's review the idea of x and y. And I think we talked about this in the last section, that when we're talking about the x value, we're talking about the domain, and when we're talking about the y value, we're talking about the range. So, the first set that we deal with is the x, and that is usually the independent variable. And then our y value is considered the dependent variable. But let's go to the middle of page 75 when it talks about a function. And it says there that a function is a correspondence between a first set, which, like I said before, the x is called the domain, and the second set, which is called the range, such that each member of the domain corresponds to exactly one member of the range. Very important to understand what that means. So if we have our domain, we'll call that x here, and we just have a list of numbers here, and then we have y. And let's say we have another set of numbers here. Okay. And what it says here is a function is a correspondence between a first set, which was right there, and a second set, which is right there, such that each member of the domain corresponds to exactly one member of the range. Okay, so if I draw a line from 1 to 6, notice how that goes to one member of the range. It corresponds to one number. And if I keep doing this, it only corresponds to one number. If I do this, that 3 still only corresponds to one number. Yes, sure, it shares it with the number 1, but it's still only going to one number. So at this point, it's still a function. And let's say that goes there. Okay, now that is a range, or I'm sorry, that is a function, but I can make it not a function. And the way I do that, I'll do it with a blue line here, is as soon as I make that 3 relate to two numbers in the range, both the 6 and the 15, it ceases to be a function, because now my domain is corresponding to two numbers in the range, the 6 and the 15, rather than exactly one member, as the definition says. And if you look at example 1 on the bottom of page 75, it gives you a couple of examples. Notice how a would be a function because each of the numbers in the domain are corresponding to only one number in the range, 36, 9, and 0. But if you look at B, actors and movies that they played in, Jamie Foxx goes to Ray, but if you look at Samuel Jackson, he was in both Coach Carter and Star Wars. So that makes it not a function because he is corresponding to two members of that range rather than just one. Okay, so example 2, just kind of go through and make sure that you understand what that function is, and that brings us up to the top of page 77. So if you look at the definition for a range on page 77, it says a relation is a correspondence between a first set called the domain and a second set called the range, such that each member of the domain corresponds to at least one member of the range. Okay. So All functions are also relations, but not all relations are functions, because let's just draw a domain here, and let's draw a range here. And if I draw these, okay, I've got a function here, because each of my left-hand column corresponds to only one in my right-hand column, my domain and range. But if I make it not a function by doing this, now that one corresponds to 3 y values, or 3 members in the domain. So it is no longer a function, but it's still a relation, because that last sentence in the definition of relation says that the range corresponds to at least one member of the domain. Okay, so that makes it work. So the domain and the range, the domain corresponds to at least member of that range, we have a relation. So if we look at example 3, all of those are ranges. But what they're asking you to do in this one is determine whether each of the following relations is a function. Notice A is not a function because the number 9 corresponds to a -5 and a 5. So that means that it is not a function. And one of the things that I tell students is, look at the x values in that list there in A. If they repeat themselves, it's not a function, because that means they relate to more than one member of the domain of the range. So notice the 9 and 9 appears twice in the first parentheses and the second one. Now look at B. We've got a -2, a 5, a 0, and a 4 as our x values. Nothing repeats, so that is a function. And if you look at C, -5, 0, and 6 are all 3 x values. Nothing the same, so they are also a function. Okay, but notice they each relate to the same number. So we have -5 relates to 3. We have 0, which relates to 3. And we also have 6 that corresponds to 3. But each one only goes to one number, so therefore it is a range. So the domain is right here, and we only have one member or one element in the domain. So let's jump to example 4. And we're looking at a little bit more about what we've got here. We've got inputs and outputs with functions where we put a number in and it kicks a number out. So if you look at example 4, we have the function of x, which is basically the domain or the y value, and we're just going to call it f of x. The function of x equals 2x squared minus x plus 3. Find each of the following. So they want us to find f of 0, and that would be if we were to put 0 in for our x values, okay, and solve it from there. And in this particular case we'd end up getting 3, because that would go away and that would go away. If we wanted to find the function of -7, and I really like you to do this, write all of this out just to make sure you get everything there correctly. And when you do this, you end up getting 108, and mostly it's because you squared that and got 49 times 2, and that gives you that number that gets you up there close to 108. That gets you up there to 98. Okay, f of 5a. All you're doing is plugging that 5a into x. So minus 5a plus 3. So obviously your answer is going to have a variable in it. In fact, in this one you're going to get, when you go through all the math, 50a squared minus 5a plus 3. And the same is going to be true when you have f to the a minus 4. you're going to put that a minus 4 in for x minus a minus 4 plus 3. And notice I put the parentheses around there to make sure that this negative here would distribute around this one and this one when you went ahead and took the parentheses off. You've got that minus sign. Okay, so when you go to example 5, we're talking about graphs of functions, which are really important. You'll be doing these a lot, and you already have done quite a few of them in intermediate algebra. But what you're going to end up with is, in this example, we've got f of x equals x squared minus 5. And what they're asking you to do here is graph that. So when you do that, you're just going to make an x and an f of x, and you're going to write that instead of y, f of x, and you're just going to put any numbers you want in there. They chose negative 3, and when you put negative 3 into x squared minus 5, it spit out a 4. And they plugged in a negative 2, and it spit out a negative 1, and you just keep going down until you get quite a few numbers. And in this case, because this is a quadratic, it's going to make a parabola. So you're going to need quite a few numbers there in order to get a good idea of what that curve is going to look like. So, you know, if this exponent was just a 1, it would be a linear equation. You'd need about 3 points, and you could draw your line. It wouldn't be any problem. But since it's got that squared, you're going to have to do more of those. So anyway, that's pretty much it for that example 5. Just plugging in numbers and see what the graph is going to end up looking like. And if you'll notice, let me see if it's back here. Yeah, at the very, very back of the book, on the cover, in fact, if you just open the cover up in the back, it gives you a library of functions. And notice that it gives you a graph, and it also gives you the type of formula that's going to give you that graph. So, you know, you've got your linear functions that are just straight lines with 1 as an exponent. If you look at that second set of equations there, your squaring functions, quadratic functions, square root functions, you can see just by the way those equations look, the general form of those equations, what the basic graph is going to look like. So when you look at one like bx cubed minus 3, it's very similar to the cubing function, which is the third row down, first column. So you have an idea of what you're getting into as far as what these will look like. So anyway, I use that back of the book there. It gets to be pretty helpful. And if you look at example 6, they give us, let's get the pen working, f of x, and they say that equals x squared minus 5, and they give us f of 3. Okay, and what they're asking for is use the graph to find each of the following function values. So to find the function value f of 3 from the graph at the left, we locate the input 3 on the horizontal axis, move vertically to the graph of the function, then move horizontally to find the output of the vertical axis. And we see that f of 3 equals 4. So if our domain is 3, our range is going to be 4, and we can find that point on that particular parabola, and it better be on the parabola because this is the formula for that parabola. So that means that when we take any number, f of negative 1 or anything, it's going to graph for us the y value, and it will always be a point that lands on that particular graph. So that can be very, very helpful. Okay, so page 80. We've got the vertical line test, and we have used this before, and you will continue to use this. In fact, later on you'll be using a horizontal line test and all these other tests to determine whether things are functions. So if it is possible for a vertical line to cross a graph more than once, then the graph is not the graph of a function. So A has something similar to this in example 7, and if we can draw a vertical line and there is no place on that graph it goes through this red line more than once, then it's a function. On the other hand, if I have that and I draw a line, it goes through that graph, it goes through that graph twice, meaning that C in example 7 is not a function. Okay, so I'm going to stop there, and we'll call this section 1.2a, and we'll continue on with 1.2b on page 81 with finding domains of functions.